Hello students, welcome once again to our channel. In this video we are going to see Unit 2 Kinematics 5 mark questions and answers. Question number 1. Explain triangular law of addition of vectors. Find out the magnitude of the resultant vector and its direction. Answer. First let us see the triangular law of addition of vectors. Represent the vectors A vector and B vector by the two adjacent sides of a triangle taken in the same order. Then the resultant is given by the third side of the triangle taken in the reverse order. Let me explain it with the help of a diagram. Now let us consider this triangle, not the whole one, OAB. OAB, this triangle let us consider. The side OA is represented by the vector A vector and AB is represented by B vector. Now the resultant, in other words the addition of these two vectors, is represented by the third side of this triangle, this one OB. This is called resultant vector, so it is denoted by capital R vector. Now these two are the adjacent side of the triangle and the vectors are taken in the same order. The direction of flow you see like that and it goes like this. But the resultant vector, its direction is in the reverse order. Here the direction of flow is not in this direction. Here in the diagram it is wrongly marked, so leave it, but in this direction, so in the reverse order. So this is the triangular law of addition of vectors. Now let us see the magnitude of the resultant vector. For that we need to draw a diagram of this kind. ONB, a right angle triangle, and again here take a point which is named as A and join A and B. Again we get a small right angle triangle ABN. Here an angle theta is formed and here an angle alpha is formed. Now the sides are marked by B cos theta and B sin theta. How they have come, let us see in the following steps. Cos theta, as all of you know, adjacent side by hypotenuse. So for this theta angle, this is the opposite side and this one is the longest side of a triangle which is hypotenuse. So AN is the adjacent side. So AN by hypotenuse is marked by B vector. But we take the magnitude of the B vector only, which is nothing but B. So we get cos theta is equal to AN by B. In the next step, if B goes this side, it gets multiplied. So we get B cos theta is equal to AN. Now let me rewrite it after rearranging this. Therefore I get AN is equal to B cos theta. Similarly, we can find out sin theta, which is nothing but opposite side by hypotenuse. Opposite side is Bn divided by hypotenuse is represented by the magnitude of the B vector, so B. So what if B goes this side? It gets multiplied. Therefore B sin theta is equal to Bn. Therefore Bn is equal to B sin theta. Now, in triangle OBN, according to Pythagoras theorem, for our better understanding, we have taken the diagram once again. In this diagram, let us consider the larger one, the larger triangle OBN, this one. For this, we are going to apply Pythagoras theorem. What does Pythagoras theorem say? The square of the hypotenuse is equal to the sum of the squares of the other two sides. That is Pythagoras theorem, which means OB squared is equal to ON squared plus BN squared. That's what Pythagoras theorem say. So in triangle OBN, according to Pythagoras theorem, OB squared is equal to ON squared plus BN squared. In other step, OB squared is equal to, how can we write ON? OA plus AN whole squared plus BN squared. Now, OB is represented by vector R. Let us take its magnitude, which is R. So R squared is equal to OA is represented by A plus AN, we have already found it. AN is equal to B cos theta plus BN is equal to B sin theta, here whole square. Now how does it look like? It looks like the algebraical formula A plus B whole square. A plus B whole squared is equal to A squared plus B squared plus 2AB. So in the next step, R squared is equal to A squared plus B squared. That is not this B squared. So B squared cos squared theta plus 2AB. That is 2AB cos theta plus B squared sin squared theta. In the next step, R squared is equal to A squared plus, for our convenience, let me write this B squared sin squared theta first and then B squared cos squared theta, and at last let me write 2AB cos theta. So in the next step, R squared is equal to A squared plus, in these two terms B squared is common, so take it out. So B squared into sin squared theta plus cos squared theta plus 2AB cos theta. R squared is equal to A squared plus B squared. As we all know, sin squared theta plus cos squared theta is equal to 1. So write it 1 plus 2AB cos theta. So R squared is equal to A squared plus B squared plus 2AB cos theta. Now what if we take the square this side? This side will become square root. So therefore, R is equal to square root of A square plus B square plus 2AB cos theta. This is the expression for resultant of magnitude of the resultant vector. Now, direction of resultant vector. Again the same, the larger triangle we take. In triangle OBN, tan alpha we take. Opposite side by adjacent side, which is equal to Bn by On, which is equal to Bn by, how to write On? OA plus An. Now let us substitute the value for Bn, which is equal to B sin theta divided by OA is equal to A plus, what is An? B cos theta. So finally we get tan alpha is equal to B sin theta by A plus B cos theta. Now keep alpha as it is and bring this term this side. Then it will become tan inverse. It means tan to the power of minus 1. Therefore we get alpha is equal to tan inverse into B sin theta by A plus B cos theta. This is the expression for direction of the resultant vector. So with this video has come to an end. Let us continue our studies with another video, with another 5 mark question in the next video.